Okay, Assalamualaikum class. So let's continue on the second part of your chapter 3, that is full wave rectifier. So in the previous video, you learned about half wave rectifier, right? So let's move the full wave rectifier. So for your full wave rectifier, so what is the function of the rectifier? So the function of the rectifier is to change AC voltage to become one polarity. So there are two types of rectifier. The first one is half wave, the second one is full wave. So in your half wave, you only have one diode. In your full wave, we have two types. One is center tap, another one is full bridge. Center tap, we have two diodes. For full bridge, you have four diodes. So the aim of your full wave, you are going to change both positive and negative towards everything will be one polarity. But for your half wave, you are going to change the sine wave to only positive will be on, but your negative cycle will be off, and then it will be on again. Okay, so this is the structure of your full wave rectifier. So for your center tap, you have two diode. For your full bridge, you have four diode. So the role of the full wave is will convert both cycles, so either negative or positive, to become one polarity. Okay, so let's start with the full wave with center tap transformer. So why we call this one center tap? Because this is a special type of transformer. So it is tapped at the center. That's why we call it center tap transformer. So the center tap transformer is a special transformer. It's not like a normal transformer. So there is a wire here. There is a distance between these two wires here. So means this wire is tapped at in between the secondary output of the transformer. Okay. So let's derive what is the V out. What is the output voltage of the center tap transformer? Okay, first of all, we start with the positive cycle. So when we say positive cycle, so you need to have your plus, minus, plus and minus. Okay, so once you have plus, minus, next step, you're going to use PLM1, where you're going to change your diode to V gamma. Okay, when the diode is turned on. So first, let's check which diode will be turned on, diode 1 or diode 2. So here is coming towards the positive. So diode 1 will be on, diode 2 will be off. So off means open circuit, on means there is a connection there. And you're going to replace your diode with what we call V gamma. So number 3, you are going to do KVL. So let's say we start the KVL at the above loop. So the loop will be from here towards your V gamma to the R out until the end of here. So what will be the loop equation here is minus Vs plus V gamma plus V out equal to 0. So this will be the equation at your positive cycle. Now let's see at the below part. This is the diode will be off, right? So there will be no loop at the below part. So there will be one loop only. So your V out equal Vs minus V gamma. So this happened at the positive cycle. So now let's see what happened at the negative cycle. So when it is at the negative cycle, okay, so let's move to the negative cycle. Means at the negative cycle, you're going to put here minus, plus, minus, plus. So now, let's check which diode will be on. So, in order for you to turn on the diode, you need to make sure here must be plus, here must be minus. So, diode 2 will be on, diode 1 will be off. So, means diode 2 on, diode 1 off. So when we are going to do the loop where the diode is on, right? So where is your loop equation here? Let's say, okay, so you're going to go through this diode, going up. You need to go through to the resistor until the end, going to the minus. Okay, now let's write the equation of the diode. So starting from, let's say, your diode here. So the diode will be replaced by V gamma, plus going up, V out minus Vs equal to 0. So your V out, it will be equal to Vs minus V gamma. So this happened at the negative cycle where diode 2 will be on, at the positive cycle where diode 1 will be on. So both are having the same equation, means at the positive cycle you have a voltage, at the negative cycle you also have the voltage. Okay, so as we know before, at your positive cycle you will have an output, at the negative cycle you also will have output. So how we are going to draw the graph? So the blue one here is your input, means at your positive cycle, what will be the V out here? V out equal Vs minus V gamma. At your negative cycle, also you having the same V out equal Vs minus V gamma, and this one will be repeated by itself. And what happened when your Vs is less than V gamma? So this condition here happen when you are having your input is less than your turn on voltage, right? It's like half wave. So this one will be off, and this region here will be on. Okay. Okay, so let's see the first example. So this is an example of the previous midterm question. So you are given here a center tap circuit. Your V gamma is 0.6. Your load here is 95. And you are given RF. So remember RF, you have DC, you have three model. One is ideal, and then you have PLM1 and PLM2. So this one is where you want to replace your diode with V gamma and RF. Okay, let's start to solve this question. Say number one, how you're going to do this one? So you are given V primary. So check if it is already given peak to peak, you are okay. But if given RMS, so you need to change your V peak value equal V RMS over square root 2. So you always use what we call peak value. So in this question, your V primary is 1:5 and your N1 over N2 is 25:1, right? So first you need to find your Vs. So use this formula first, N1 over N2. So your primary here is 1:5. You don't know your Vs equal 25 divided by 1. So you can get your Vs is equal 1:5 divided by 25. So this one will be equal to 5. So once you got your Vs here, so the question say find the V out. Okay, but the question give RF. So let's start with the positive cycle. So what does it mean by positive cycle? Means you need to put here plus minus, right? So plus minus means diode 1 will be on, diode 2 will be off. So when diode 1 on, the diode 2 off, so your loop is above here. So let's start to have the loop minus Vs plus. Okay, now you have a diode, but your diode will be replaced by PLM2, means you're going to have V gamma in series with RF. So inside here where you are going to put V gamma plus RF ID. So the whole here is actually your diode. And then continue with the equation. You have V out, means here you have R ID will be equal to 0. Okay, so replace the value, so it become minus 5. What is your V gamma? 0.6. What is your RF? 15. You don't know your ID. What is your R? R is 95. ID equal to 0. Okay, please remember to put peak here. So all these are peak value because your input is AC, right? And then you can get your ID peak is equal to, once you got your ID, the question say V out. So directly find your V out, means 0.04 multiplied by 95, we can get 3.8 volt. Okay, so question number 2, you need to sketch. So when it says sketch, you need to sketch first your input. So this will be your input plus minus. So this is V and V. Don't forget to label here second. So what is your input peak here is your Vs peak. So just now your Vs peak here is equal to 5. Okay. Okay, next let's plot the output. So your output will be 3.8. So means you're having a smaller semicircle here. The peak here is 3.8. This region, the diode is off. And then what happened at the negative cycle? This one is at positive, right? At the negative cycle, you're going to put here minus plus. So this one will be on, this one will be off, and then you're having the same load and same equation, right? So then directly this one will be another negative cycle. So this is the shape of your output value. And don't forget to label the peak 5 and 3.8. So this is how you're going to solve the question. Okay, so this is what we call center tap transformer full bridge rectifier, where we have two diode and we will convert both positive and negative cycle to one polarity.